Hi, my name is Evan, and I'm from the University of Virginia Motion Analysis and Motor Performance Lab over in the United States. This video is about the work we did predicting gait events from the handle forces of an instrumented posterior walker. The motivation behind this project is to try and understand how assistive devices affect gait, so that we can develop devices that assist the user in the best possible way. Many individuals with walking disorders use assistive devices to aid their mobility. Specifically, posterior walkers are used by people with cerebral palsy, or CP, to increase their stability by widening their base of support. Posterior walkers also enable CP users to utilize their upper body to reduce some of their body weight load from their lower limbs. This can be very useful. However, the benefits of using this walker come at an increased metabolic cost of pulling the walker. We think this cost could be negated by powering the walker and injecting energy at specific points during the gait cycle, such as push-off. However, in order to do this, we need to know the location of the user in their gait cycle, which brings us to the aim of this work. We aim to predict gait events of a human walking with a posterior walker from the forces applied at the handles to be used as input for a controllable powered walker. We hypothesize that because gait is periodic, hand forces on a posterior walker will also be periodic. We can then correlate these periodic force events of the hands to the known periodic gait events. To test these hypotheses, we collected walking data of 9 children typically developing and 14 children with CP. As they walked at their self-selected comfortable pace over level ground, they were pulling our walker, which has been instrumented at both handles with 6 degrees of freedom load cells. From this experiment, we found that users periodically load and unload the handles of the walker during gait, as can be seen here by the average of the group of children typically developing. Additionally, this periodic handle loading can be correlated to gait events. Specifically, ipsilateral foot strike can be predicted best by the maximum seen in the vertical loading on the contralateral handle following contralateral foot strike. Ipsilateral foot off can be predicted best by the mid-stance minimum seen in the axial loading on the contralateral handle. Since we can predict the ipsilateral events of both the left and right strides, we are also able to predict the contralateral events, given these events are the ipsilateral events with respect to the overlapping stride. So in conclusion, there are identifiable and repeating force events that precede gait events as a person walks with a posterior walker. This will allow us to use the hand forces as input to control the assistance given to the user by a powered walker. Thank you for your time, and if you would like to learn more, details about this effort can be found on our poster in Session B, number 117. I hope you enjoyed this explanation, and feel free to reach out to me with any questions you may have.